So today's lesson is being able to graph using horizontal and vertical translations. And we're going to talk about all different types of graphs, but the first two we're going to look at are linear and quadratic. Remember, linear is just because we're raising the variable x to the first power. Here we have a second power, so that's the quadratic. Just so you remember, we also evaluate functions. Y is also f of x. We can call this axis the f of x axis, just as well as calling it the y axis. So we'll talk about that as we, those are things that we've done in the past, being able to find the other points. So the horizontal translation is anything that occurs within parentheses with the x. And remember, you always go the opposite direction because you're trying to make that equal to 0. So the horizontal translation in this case is 1. The vertical translation is anything that is attached. This is when we've already solved for y. Sometimes you might have it in point slope form, which we've learned, and then you have to get it where the y is by itself. So this would be positive 2. You always take the actual value there. And then we have to plot that point. That is our main point to begin with. So we're going to put that in our table in the middle. So 1, 2, we plot 1, 2. And then remember how we fill this out. We go back 2 positions on the x-axis, and we go up 2 in order to plot those points. So if you plug in 0 for the x, and this is the things that you've done before where we find the function evaluated at 0. If 0 minus 1 is negative 1 times negative 3, negative 1 times 3 is negative 3 plus 2 is negative 1. So 0, negative 1, and negative 1, plug that in, you get negative 1 minus 1, which is negative 2. Negative 2 times 3 is negative 6 plus 4. Negative 6 plus 2 is negative 4. So it would be negative 1, negative 4. And if you put in 2, well, you go the other way. 2 minus 1 is 1. 1 times 3 is 3. 3 plus 2 is 5. So 2, 5. And then we've talked about patterns before, so you would be able to get that. But you need to see at least 3 points. And then you can graph that through the line. Not a very good job by me. All right, then what happens if you change the type of problem it is? So now we have a quadratic, and the idea is still the same. We look inside the parentheses to find the horizontal shift. And remember, if you set x minus 1 equal to 0, I should have done this on the last one, you find the shift is x equal to 1. That's your horizontal translation or horizontal shift. And then your vertical translation is, again, anything attached at the end, so that's a 2. So we're just trying to show you that it's really the same concept. So you're going to put a 1, 2 is the main point here, so 1, 2. And we'll start learning more about terms later, but that will be called the vertex of the quadratic. So watch what happens when we plug in 0 and negative 1 and 2 and 3 in this one. If you plug in negative 1 in here, negative 1 minus 1 is negative 2, but when you square negative 2, you actually get 4. 4 times 3 is 12. 12 plus 2, let's put in 0, sorry. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 times 3 is 3. 3 plus 2 is 5. So you get 0, 5. And then let's go 1 to the right to make things a little bit easier here. So put in a 2 here. 2 minus 1 is 1. 1 squared is 1 times 3 is 3. 3 plus 2 is 5. But remember, we've talked about some of these quadratics having something called an axis of symmetry, but we'll talk more about that in some of the other points. But if we plug in negative 1 and 3, the points would be up here somewhere, and you'll notice that quadratics are like that, but the shift is the same. Okay, now we're back, and like we said, we would apply this to other situations too. So remember, we talked a little bit about radicals. How do you graph this, this equation up here? So again, you have to treat a radical like a parentheses. I think we've talked a little bit about the fact that a square root is really a power, is a 1/2 power. It'd be the same thing as taking x minus 1 to the 1/2 power there. But we're going to deal with it as a radical. So again, what is the shift inside the parentheses? It is the opposite of negative 1. So we have positive 1. And then what is the shift outside? That is a 2. So again, we're starting at 1, 2. If you notice, all 3 of our graphs have done that. Now this one's a little trickier because as you go backwards and you go forwards, let's see, let's just go one back and then we'll show you what happens. If you go 0 in there, 0 minus 1 is a -1. Now, we do not have a value for the square root of -1 at this point. Later on you'll learn a little bit more about imaginary numbers, but they are not graphed at this point. So because those are not real numbers, we are not going to have anything beyond this. And again, this will all lead into our domain and range concepts as well that we've been learning about. And then if we plug in 2, 2 minus 1 is 1. Square root of 1 is 1. 1 times 3 is 3, 3 plus 2 is 5. So we get 2, 5. Let me just make sure I did that right again. Okay, and then now 3 is not a really good number to put in because 3 minus 1 is 2. We're going to try to find another number that put in there that's actually a perfect square. So as you move your way up, 3 minus 1 is 2, 4 minus 1 is 3. We finally get to 5. So 5 minus 1 is 4, but the square root of 4 is 2. 2 times 3 is 6 plus 2 is 8. So 5 actually gives you 8. Remember, we've looked at any of these before, the generic ones that we're relating these to. That is the path that this is going to take. But notice it has actually a starting point. It's not like the line or the parabola where it went infinitely in both directions. So your job is now I'd like you to see if you can graph this line, or this equation, I should say. That is what you're going to do right now.